Imagine an AI that can reason through super complex logic, that can analyze huge documents, and even write code like one of the top models out there, but at a tiny, tiny fraction of the cost. Well, that's exactly what we're looking at today with Baidu's ERNIE 4.5. Okay, let's dive right into this. So, here's the billion-dollar question, right? Is it actually possible to get that human-like reasoning power we see in the giant models without the massive, massive price tag that usually comes with it? I mean, this is the promise that could completely change who gets to build the future with AI. And this slide gets right to the core of it. On one side, you've got the immense power we've come to expect from top-tier AI. We're talking deep reasoning, complex logic, the whole shebang. But on the other side, you have what makes this model so disruptive. It's hyper-efficient, it's accessible, and maybe most importantly, it's open source. Now that is a powerful combination. All right, so let's start by unpacking what makes this a new kind of AI. Because we're moving past models that just spit back answers they've memorized. We're stepping into a new era of models that are designed for genuine, step-by-step reasoning. So, say hello to ERNIE 4.5. The full name is ERNIE 4.5-21B-A3B Thinking. And that last word, thinking, that's the key. This thing was purpose-built from the ground up to tackle the really heavy lifting in fields that require deep logical thought, like mathematics, complex science, and formal logic. And check out this number. It represents the sheer scale this thing can handle, a 128,000 token context window. Now, to put that in perspective for you, that's like feeding it an entire novel, like the whole book, and asking it to analyze themes and characters all in one shot. Which, of course, brings us to the big question. How does it deliver that kind of insane power so efficiently? This is where the underlying architecture gets really, really clever. The secret is a technology called Mixture of Experts, or MOE for short. Now, instead of firing up the entire massive AI brain for every single little task, MOE intelligently activates only the specific parts, the so-called experts, that are actually needed for the job. This is the absolute key to its incredible efficiency. Here's a great way to see the difference. Traditional dense models, well, they use their entire network for everything. It's powerful, yeah, for sure, but it's kind of like using a supercomputer to run a calculator, just incredibly wasteful. MOE models are way smarter, activating only the specialized neurons that are required for the task at hand. The best way to think about it is like a team of specialists. When a problem comes in, a smart little router figures out exactly who needs to see it. Is it a math problem? Okay, send it to the math experts. A coding question? The code experts get to work. This way, you get a highly specialized, expert answer without wasting any resources at all. All right, so the theory sounds fantastic, but how does this efficiency-focused model actually perform when it goes head-to-head with the industry giants? Let's take a look at the numbers. So this is really the crucial point, isn't it? Performance. Can a model that only has about 3 billion active parameters per task really compete with models that are just vastly, vastly larger? Well, the benchmark results are pretty surprising. So let's start with logical reasoning. On a benchmark called Zebra Logic, ERNIE 4.5 scores an impressive 89.8. And let me tell you, this is a very, very strong score. It really shows its capability for complex, multi-step thinking. And the story is pretty much the same with coding. Scoring over 90 on the really demanding Human Eval Plus benchmark is a crystal clear indicator of its power. For developers, this proves ERNIE 4.5 isn't just a thinker, it's a seriously capable tool for generating and understanding code. So the performance is clearly there. It's competitive, it can hang with the big dogs. But honestly, that's not even the most exciting part of this story. The real game changer is the cost. And this is the result, a cost reduction of up to 99% for processing 1 million tokens, compared to some of the biggest closed-source models out there. This isn't just a little improvement, it's a fundamental shift. It totally democratizes access to high-end AI. So, with this incredible combination of raw power and super low cost, where does the rubber actually meet the road? Let's explore some of the practical applications. The possibilities here are just vast. I mean, imagine researchers analyzing massive data sets in minutes or legal teams sifting through thousands of documents instantly.
In education, it could power affordable, high-quality tutors for every single student, while developers could use it to build sophisticated AI applications that were just completely out of reach before.
So, what's the final verdict? Well, I think it's really important to have a balanced view, to look at both the incredible potential and, the practical realities of using a model like this. On the pro side, you've got world-class reasoning, that massive context window, and extreme cost efficiency, all wrapped up in an open source package. Now, on the con side, the specialized MOE architecture does require some specific infrastructure, its community is still growing, and for some really, really niche tasks, a giant dense model might still have an edge. But for most people, the pros here are just overwhelming.
And that leaves us with this final, really powerful question. You see, ERNIE 4.5 isn't just another model. It's a signpost for the future. It represents a world where the absolute highest levels of AI reasoning are no longer locked away behind massive paywalls. So what happens when that kind of power is put into the hands of every researcher, developer, and creator on the planet? The possibilities are truly exciting to think about.